Recursion is the core pattern of complex systems. Recursion is one of the most fundamental structures in science and mathematics. It describes any process that defines itself through its previous state, where the output of one step becomes the input for the next. In computing, this is expressed in a recursive function, a loop that repeats until it reaches a stable condition or base case. This simple principle allows for the creation of highly complex results from minimal rules. Mathematically, recursion underlies many natural sequences and structures. The Fibonacci sequence is a classic example, but the same principle appears in iterative systems that generate fractals or simulate population dynamics. Each step depends on feedback from the one before, allowing complexity to grow from repetition and adjustment rather than external design. In physics and natural science, recursion shows up wherever feedback is present. Climate regulations, neural signaling, and even gravitational systems all operate through recursive processes. Each state influences the next through continuous feedback, maintaining balance while allowing evolution. This property, the ability to generate order and adaptation through self-reference, is what makes recursion essential to both stability and change. Biological systems rely on recursion at every level. DNA replication, cellular regulation, and neural computation all use recursive loops to monitor and correct their own behavior. Evolution itself can be seen as a recursive algorithm. Variation, selection, and inheritance repeating through time, each cycle refining what came before. This process is not random. It's structured through feedback that preserves what works while testing new configurations. In cognitive science, recursion is considered a defining feature of human intelligence. Language depends on it. Grammar allows us to nest phrases within phrases, generating infinite meaning from finite rules. Thought itself is recursive. The brain doesn't just process information, it models its own processing. This meta-level reflection, thinking about thinking, is what allows abstract reasoning, memory, and self-awareness to emerge. At the physical level, recursion also appears in fundamental laws. Quantum systems evolve through iterative interactions of probability, while general relativity describes space-time curvature feedback into itself through energy and mass. These recursive relationships between cause and effect form the basis for how the universe maintains coherence while remaining dynamic. Ultimately, recursion is not just a mathematical concept. It's a structural property of reality. It explains how systems can be self-generating, self-correcting, and self-aware. Whether in computation, biology, or physics, recursion provides the mechanism through which complexity emerges without external direction.